Hello, my name is Andrea Frittoli. I'm an open source developer advocate at IBM. And today I'm here to talk to you about cloud-native CD pipelines with Tekton. So after a brief intro to Tekton, we'll discuss about what we call plumbing and specifically CD pipelines implemented for Tekton. I will present a demo about that and discuss lessons learned from this experience. But first of all, what is Tekton? So Tekton is an open source framework for creating and building CI/CD pipelines or systems. It is cloud native and it's governed by the Continuous Delivery Foundation. And in fact, it was one of the founding project of the foundation itself. Tekton benefits from contribution from several companies like Google, Red Hat, IBM, CloudBees, Pivotal, and many more. And it also has a thriving community of users that are building solutions, products, or offerings around Tekton. So what makes Tekton different from other solutions in the ecosystem? Well, Tekton is not opinionated on how you build your pipeline, so it gives developers maximum flexibility in how CD pipelines and CI pipelines are created. And it aims for standardization. So the idea is to create reusable building blocks for your CI/CD pipelines that gives you an abstraction layer on top of the tooling that you use. So you may switch the toolings but maintain the same pipelines. And also Tekton aims to work well with other CI/CD systems to give you interoperability. So once you have the building blocks, you may decide to change infrastructure on top of Tekton, but continue reusing the same building blocks. You can benefit using Tekton from cloud native out of the box, so you get things like scalability and serverless execution right away. Tekton is actually an umbrella of projects. So the core building blocks are pipelines that allow you to define your tasks and pipelines and workflows as well, and triggers, which is about how you run the pipelines as a result of events. Tekton comes with a rich set of tooling as well, like a web UI or a dashboard for browsing through your pipeline runs, look at the logs and so forth. What we call TKN, so the CLI for interacting with Tekton and controlling everything about Tekton. And finally, an operator to manage installation, deployment, upgrades of Tekton. We also have a catalog and a hub, which is about providing existing building blocks for creating your pipelines and discovering them through the hub and consuming them in your pipeline as well in the near future. And also we run a number of experiments like DSLs on top of Tekton and providing permanent storage and ability to query the execution history of your pipelines and so forth. We're also looking into supply chain security and etc. So if we want to go a bit deeper into Tekton, in terms of pipelines, we define a number of primitives, and the smallest one is a step, which is actually a command which is executed in a container, which comes with the usual perks from container like volumes, environment variables, etc. Then the next one, which is an extension of Kubernetes API or also custom resource definition, CRD, is a task. And the task is a sequence of steps executed within the same pod, so they're running on the same node. And finally, pipeline is a set of tasks that could be executed in sequence or could be executed in parallel or a combination. So it's a graph in general. So tasks and pipelines, they can use workspaces for storage and sharing storage between tasks within the same pipeline. They come with input parameters and results, which are kind of the output parameters of tasks and pipelines. So all this is about the static definition of your pipelines, and then to actually run a pipeline or a task, you will need to create a task run or a pipeline run, which binds the static definition to the dynamic resources, which specific PVC you want to use or which parameters are going to be passed in. So also similarly, triggers extends the Kubernetes API using CRDs and defines a few primitives. The core one is the event listener, which creates a sink or for the events to be sent to. So it's a Kubernetes service at the end. And event comes usually with a payload. So trigger bindings are about extracting information from the payload into parameters, which are then passed to trigger templates that define which kind of pipeline run and task runs are going to be executed. On top of that, we also have interceptors that can be used to filter and validate the events that are coming in, and also to enrich the payload with extra data if required. So now that we get an idea of what Tekton is about, let's look into plumbing. Why do we call it plumbing, first of all? So, well, if you look at the dictionary, plumbing is the set of systems and pipes and so forth that basically bring tap water in your house and heating and other services like that. So in terms of Tekton infrastructure, with plumbing we mean the set of services and software and configuration that are used to provide releases and building and testing Tekton itself. So Tekton comes from the Kubernetes, and more specifically from the Knative ecosystem originally. And so we kind of inherited the whole CI setup, and we started using Prow, like a mini project in that ecosystem. And then we started building our first 1 or 2 releases manually. But soon enough, we moved into automating things, and we wanted to use Tekton for that. And ultimately, the goal was to use Tekton for as much as possible of our automation needs, so for our plumbing needs. So we started looking into what we call dogfooding, using Tekton for building, releasing and testing Tekton. And specifically on the CD side of things, we incrementally built and added functionality for having nightly and full releases, for building container images, both on demand and nightly. Also, our CD pipelines are manifests, which are stored in Git, so we need to deploy those manifests to our plumbing cluster, which we call dogfooding. And so we deploy those pipelines and the configs that need on hourly basis using Tekton pipelines. So we started deploying Tekton itself using Tekton, and finally we added notification capabilities for monitoring our pipelines, also based on Tekton pipelines. So let's dive a bit deeper into the CD pipelines I just talked about. So what do they look like? So the setup is described in this busy diagram, if you will, but let's just deconstruct it and understand what's going on here. So in the middle, you've got the CD pipelines themselves. So the top one, for instance, is about generating nightly releases. So this is a pipeline, and it will run unit test and build test, and finally, if everything goes well, publish the images. And then you have one about deploying pipeline as code, or updating config maps, deploying Tekton services, and so forth. So all the events that trigger those pipelines are generated by Kubernetes cron jobs, which are created out of templates using Customize. And those Kubernetes cron jobs, they send a JSON payload to an event listener, here the blue box, that receives the events, uses a filter to understand which CD pipeline we want to trigger. It uses bindings to extract information and pass it into the templates, and then finally run the pipeline. So Tekton can generate cloud events and cloud events for everything that happens about task runs and pipeline runs. So for instance, when we start a nightly release, or when we are completing it, whether it's successful or failed, cloud events are going to be generated. And we have the system configured so that all the events are going to one single sink, which is yet another event listener, here the blue box on the right hand side. And this event listener, what it does, it collects all the events from the CD pipelines. and it filters them and it recognizes, for instance, if one of the pipelines failed. And then it extracts the information from that pipeline using bindings again, and it passes that information into a notification task, which is executing then to send a notification into a dedicated channel on Slack that alerts the build cup of the day. So with this setup, we have cloud-native pipelines that are schedulable, reusable, because we can have multiple configuration for each of them. They're kind of observable, so we have monitoring in place, we have metrics that are generated, but we are working towards making them more properly observable. Are they interoperable? Well, this is the aim really, and we are working with the SIG, interoperability SIG from the CD Foundation, to define a shared vocabulary for events. So right now the events are Tekton specific, but hopefully in future will be common ones, so that we use a common dictionary, and this should allow to have integration between Tekton and other solutions in the CI/CD space from the CD Foundation or even outside that can be then trigger pipelines across different platforms. Are they testable? Well, let's dive into that. So we started building several CD pipelines, and initially the process was create the pipeline, maybe bring up your kind cluster locally, run the pipeline there and see if everything went well. Or in some cases we get confidence, so we try the change, we put it in a PR, oh, it looks okay, so let's deploy it, and then maybe it works, maybe it doesn't. So we were not really satisfied with this process, and we decided that we wanted to be able to test our CD pipelines as part of our continuous integration. So this diagram shows how we did that, and I'm going to demo it in a moment. So in the middle here, in this case, we have our CI pipelines. The setup is similar, just in this case, the events come from GitHub. So a developer created a PR, and maybe this PR includes a change to one of the CD pipelines. So there is a number of filters that we need to execute to validate that the event is one that we care about, and it's a valid one, and it's coming from a user that we trust, for instance, because we don't want to run random code from the internet. Someone said, think a PR, oh, let's run this. So we extract information, pass it through the templates into the CI pipelines. And we have some CI pipelines that will do usual things like YAML linter, Golang linter, or building container images and so forth. But we have some additional ones here. So the top one, if it recognizes that the PR is about trying to change one of the CD pipelines, what it does, it creates a new namespace in the cluster, and it deploys a copy of the entire CD system in that namespace. And this copy is actually is created out of the definition of the PR of the CD system in the PR. So it includes the CD pipelines as defined there. So this is step 2. And then we have another task that waits for the first one to complete, and then it sends a trigger using a cloud event into the event listener. So the entries event listener in the new namespace. So in this case, the trigger normally is sent by a Kubernetes cron job, but here we send it directly with a cloud event. And then the CD pipelines runs as normal, and the job here in the CI job waits for the CD pipeline to complete, and it verifies that it was running correctly. So let's have a look at this into action. I've got my Kubernetes cluster here on IBM Cloud. I've got a full replica of the upstream CI/CD system, so including the various CD pipelines, and I can look at those pipelines through the cron jobs that trigger them. And for this demo, we're going to use the config map CD trigger label sync that deploys a config map with the definition of the labels that we use for GitHub. So I can trigger this with a trick, just using kubectl create job from the cron job, and this triggers my pipeline on demand which is really handy. And also I can look at the logs of recent task runs, and you can see one was started just 9 seconds ago. This is the one we just triggered. And here is the entire log. So we clone the git repo and set up a kube config for interacting with the cluster. And then we made a diff of the config, but it doesn't tell us much more. So in the demo, I showed that we can update this CD pipeline, make it a bit more verbose or useful, and run that as part of CI without merging the code. So we can see the pipeline running. We can check it behaves the way we want to. And then after the code is reviewed and approved, it will merge and it will actually be deployed into production. So let's have a look. I've got the branch ready for that. So this is the CD pipeline for the config map deployment. And yeah, I'm adding a step to greet everyone before we start doing anything, which is just nice. And then adding verbosity. So adding verbosity to the fetch config and also to the deploy step, and telling whether we are deploying something or we are not. And I got a second branch up where the same branch, second commit, where I'm adding a label so we can see something being deployed, in fact. So let's make a small change. Hello, cdcon. And push this branch up. And you can see that as soon as this is pushed, there are pipeline runs that are started in this Tekton CI namespace, which is where CI jobs are running. And we have Tekton YAML lint, which checks for validity of YAML, and then we have a few jobs, TKN build, hub, kubectl build, those are building container images. Those are started, but they are not actually going to be reporting anything because we didn't change any of these images. So you can see they're going to succeeded, completed. So that means that the tasks within the pipeline were actually skipped. And then we have two pipelines here. The plumbing test Tekton CD one is responsible for creating a new namespace and deploying the entire CD system into this namespace from the PR as things are defined in the PR. And then the first one, CD config map label triggers, is waiting for that to be finished and then triggering the CD pipeline and waiting for the pipeline to finish and reporting the result. And while that is running, I also wanted to show you an interesting use case of a malicious user trying to abuse the system, because we run the PR, we run the pipeline as it is defined in the PR. Sorry, they're all both PR. And so this AF bot user is not part of the organization or the container group for my fork GitHub repo. So let's have a look at the branch first. And you can see we are trying to expose some tokens from the service account. So we don't want that normally. And let's create the PR. Okay. And so we can switch back to the list of pipelines. And you can see again, YAML lint has been triggered, and kubectl build and hub build, TKN build have been triggered, but the pipelines, the CI pipelines to test CD pipelines have not been triggered because the user is not authorized. And we can go and check what happened also via the GitHub UI. So here is our malicious code PR. And it has this check running. Probably already finished. Yeah, it's going to report soon. And then we have the other check, the other PR. Instead, is running two checks. So the YAML lint and this that tested the CD pipeline was successful. Let's have a look at it. So you can see the deploy config map step. this is sending the trigger to the newly created CD system and extracting the event ID, and then it's waiting for it to complete, and it's giving us a link as well to the where we can follow the CD pipeline has been executed, and you can see that it is running in a dedicated namespace, not in Tekton CI but in PR26, which matches the number of the PR that was created here. And yeah, so here is our step, our grading step. Hello everyone. And then the fetch config, and in the deploy config you can see now it's showing the diff between the original config map and the new one in this PR. And yeah, config detected and updating it, so it was replaced. So this is much better. And just to stress this again, this is being executed as part of CI, but it's not merged yet. So the original CD pipeline is still the way it was until the PR is approved and merged. So let's go back to the presentation. What did we learn from this exercise, setting up the CD pipelines? Well, Tekton gave us really full flexibility in setting things up the way we wanted, and it allowed for incremental implementation. So we started from PRAW and manual CD, and we incrementally added functionality and moved things away from the CI side from PRAW to Tekton, but still the two coexist. But it's a lot of YAML, so we use customize to reduce the boilerplate code, but still it is quite verbose. And here maybe a DSL could help reducing the amount of boilerplate, and we're looking into that. So events and triggers prove to be quite useful because they are good for testing. They can be used to trigger the CD pipelines using cron, using a schedule, but they could be hooked into CI jobs to test the CD pipelines as well. And they might be good for interoperability. As I mentioned earlier, we're working with the CDF interoperability group, and so generating events from CD pipelines might be helpful to integrate with other systems. And so in terms of implementation, when everything that we manual eventually failed, and then we started automating and things failed as well, because when you automate and then there is churn, you change things and so they don't behave as you expected to. And sometimes this is down to documentation, because there is a different expectation when reading the code of the behavior that should be happening. But it's also very important to plan for testing and monitoring your pipelines so that you can see the changes before they are merged. Also running CI/CD and CD pipelines, especially using Tekton, leads to so many resources in your cluster. All the runs, for instance. So it's a very good idea to use labels, and some of them are set up by Tekton natively. And you can use labels to filter your resources, to search for them, and you can create deep links with a dashboard. And it's also a good idea to archive logs and YAMLs, and this is we have an experimental project for that, and to clean up the cluster regularly to keep it clean with fewer resources in place. And also we realized when building CD pipelines that we don't have everything that we need, so we need more functionality from Tekton's side or more pipes to be able to do everything that we want to do. For instance, we have use cases where we want to run the same pipeline for a number of different things, and there it would be good to have things like loop and switch construct available, and we're working on that. We're working on providing things like multi-architecture builds, so we can run Tekton on a different kind of hardware. And yeah, so things like custom tasks, for instance, because not everything must be a pod. So you might want to have a step in your pipeline where you're looking for human approval from someone, or just waiting for a certain amount of time and not using Kubernetes resources for that. So yeah, specifically for CI, results, API, log archival, things that we are looking into, and flag analysis. So please do come and join us. We are a welcoming and friendly community. We are on Slack. Here is the link. So yeah, we're looking forward to meeting you and seeing your contributions. Thank you for listening to my presentation today. And here is a list of a few references that might be useful for you. So you will have the slides. So don't worry about taking a snapshot here. And yeah, thank you again and goodbye. So hello everyone. Hopefully you can see and hear me. So thanks for joining the session today. There's one question from the chat. Let's start with that. So the question is, many JS tools calculate their parallelism based on info on the proxy view info. Just any thoughts on the Tekton project, how to set resources to tasks and pipelines? So yeah, that's a very good question. Thanks for that. So two things. In terms of tasks or task runs, we have the ability to configure resources, to request resources. They can be set for the steps, but in general, when scheduling a task on a node or task run, I should say, we request the maximum that is requested by any of the steps, because steps are executed sequentially, so we just want to take the largest step and request for that. And so that is the amount of resources that you can configure for your task. Another request that we often get is about maximum parallelism for tasks or pipelines, and that's something that is not supported yet out of the box from by Tekton, but it's something that we definitely want to support, and it's in our roadmap, and we are looking into ways of implementing that. And thanks for the feedback. Is there any other question? So I think the slides, if anyone is interested, should be available on Shed, at least. I don't know if there is any other way slides will be made available, but if you're interested, you can also reach me on Twitter or find me in the Tekton Slack, and I'm happy to share the slides. Also, I wanted to mention that we have a lot of space for contribution in many different areas. I mean, really from things like use cases. If you're working on CI/CD, you want to share use cases or features that you'd like to have, or yeah, so infrastructure, like the dog fooding that I talked about, and yeah, from the main project. So if you're developing Golang or JavaScript for the dashboard, so yeah, any type of contribution really is welcome. So feel free to join our Slack. Don't be shy, and we look forward really to see you there. Okay, I think we are at time. So again, thank you for joining today, and feel free to reach out to me directly if you have any question in the future. Bye-bye.